Here we go. Unit 4 test review. This is the third page. These are going to be all about proofs. I might try to do page 3 and 4 in one video. Let's just see how long these take. All right. Now, we are given that AB and BC are perpendicular. So AB and BC are perpendicular. We are also given that DC and BC are perpendicular. And we are given DB. DB is congruent to AC. All right, now from here, I know I've been talking a lot about these overlapping triangles, and it turns out this one is going to be an HL kind of proof. Let's see here, but it's kind of hard to see that as is because we have these overlapping triangles, right? So what I'm going to do is I'm going to split them apart. All right, so we kind of have these red triangles and we have the blue triangles. And if we want to think about it, what we're going to have, oh man, I traced that really badly, sorry. This red triangle, we have point B, we have point D, and we have C. And then the blue triangle, we have A, B, and C. A, B, and C. All right, so we know AB and BC are perpendicular. All right, so that's just given. And we know DC and CB are also perpendicular. Again, that's given. Now it's a little bit easier to see AC. Segment AC and segment BD are congruent. All right, so that's just given information. Now, the one that is hard to see when they're split up, but easy to see when they're together, is they do have a shared side. Both of them have segment BC. Right? So since both of these segments have BC, that's this shared side kind of down at the bottom, we know that has to be congruent. So if we just, I'm just going to do this real quick. I'm not going to write all this down because I can't even get my statements and my reasons in the right order. We have our statements. We have our reasons. All right, so step 1, we got all of our given information. Just everything is perpendicular. All right, so that's given. All right, now step 2. Step 2, we can use the reflexive property. So we know BC is congruent to BC. That is just reflexive. I'm going to abbreviate a lot here. That's reflexive. All right, now if we look at triangle ABC and triangle DBC, all right, these are two congruent triangles by the hypotenuse leg theorem. So remember, AC is a hypotenuse because it is across from our 90-degree angle. All right, BD is the hypotenuse because that is also across from the 90-degree angle. All right, BC is the leg on both of these. So we have the hypotenuses, whatever you want to call it. Those are congruent. The legs are congruent. It's a right triangle because we have that 90-degree angle. So we know that these triangles are congruent by the HL theorem. All right, so these two triangles are the same. So you can say triangle ABC is going to be congruent to triangle, let's see if I'm going to go ABC. We have to go DCB, DCB. All right, and the very next step is we can finish this off. We can say angle A is congruent to angle D. All right, and that is CP, CTC. All right, so that was only a 4-step proof. All right, so it looks more complicated than it really is. So again, split those triangles up. That's going to make your life just a little bit easier. All right, next one, AE bisects angle BED. All right, we are bisecting an angle. That means we are chopping it into two congruent angles. So here's what I'm going to do. We know BE is congruent to ED. So let's focus on these two red triangles right now. All right, I'm going to pull these down here. All right, we have A, B, E, and D. All right, this is angle 1, and we have an angle 2. So now if we just look at, I'll take my time on this, when we for statements, and we have our reasons. Okay. So AE, step 1, AE bisects BED, angle BED. That's given. All right. Now from here, we also know BE is congruent to ED. All right. All of that is given. So now let's just try to identify, or I guess establish what that means. BE is congruent to ED. All right. Very straightforward. BED is this entire angle. All right. BED is that whole thing. So if AE is bisecting that angle, it's making two congruent angles. So namely, angle 1 and angle 2. All right, so we can say angle 1 is congruent to angle 2. How do we know that? Because that's just the definition of bisect. That's what bisect means, makes two equal angles. So the definition of bisect. All right, now, from here, we know BE is congruent to ED. That was given. We just said angle 1 is going to be equal to angle 2. And now for step 3, we have a reflexive side. We can say AE is congruent to itself, is congruent to AE. All right, that's just going to be reflexive. Okay. So I'll put 2 tick marks in here. So now, look at those 2 triangles. We have an SAS kind of triangle. So step 4 here. We know we have an SAS, a side, angle side theorem. So we can say the triangles are congruent. So I'm going to go AEB, triangle AEB is going to be congruent to triangle AED. All right. Now, keep in mind, we are trying to show angle 3 and 4 are congruent. So we kind of have to work our way over to the right side of this big picture. So angle 3 and angle 4. Let's just kind of talk about what those 2 triangles belong to. So we have this blue triangle, BEC and DEC with the blue triangles. That has angle 3 and 4 on it. But notice how we also have the big outside triangles I'm going to draw in green. All right, so angle 3 and angle 4 also belong to the green triangle, the big outside triangles. Now, we started with the left triangle that I drew in red. We kind of have some choices. Do we want to work with the blue triangle, show that one's congruent, or do we want to work with the green triangle and show that that one is congruent? And I would recommend using the green triangle, because if I just draw this red one back in here, notice how the green and the red, they have a whole bunch of stuff in common that we can establish is congruent using CP/CTC. We know, right, we showed the red ones were congruent. So why don't we say that these 2 angles that I'm drawing in orange, so angle BAE and angle DAE, those are congruent by CP/CTC. All right, so I'm going to say that. So I'm going to say step 5. All right, we can say, I already forgot the letters, angle DAE, angle DAE is congruent to angle BAE. All right, that is by CP/CTC. All right, so now if we look at the green triangles here, so I'm going to just take the green triangles and I'm going to try to move it down here. We just said that these two angles are congruent. All right, so we had, this was point A, this is point B, this is point D, and I think this is point C. Let me double check. Yeah, all right. So BAE is congruent to DAE, and keep in mind there's kind of that middle point right here, that's point E. All right, so those angles are congruent. Now, if we look at the red one and the green one again, they still have another kind of section that they overlap. So we can say AB is congruent to AD as well, right? Both the red triangle and the green triangle have segments AB and segments AD. So let's get that those are congruent. We know that AB and AD are congruent. So AB is congruent to AD. All right, and we know that again by CP-CTC, right? We showed that the red triangles were congruent through SAS, and we used CP-CTC twice now to show that these angles were congruent. So we got an angle and we have a side. So now if we look at the green triangle, let's grab that side that they share in the middle, right? So if we look at step 6, we can say side AC is congruent to itself. That is going to be reflexive. So, and so those are congruent. We have another SAS triangle. If you look at the green one, we have AB is congruent to AD, that's a side. We have angle BAC is congruent to angle DAC, that's an angle. And then AC is congruent to AC, that's another side. So if we put those three things together, we can say in step 7, triangle ABC. ABC is congruent to triangle ADC. All right, now how do we know that? We know that by the SAS, the side angle side theorem. So now we know the outside triangle in our main picture is congruent to the bottom one. So the top big triangle is congruent to the top bottom triangle. Now keep in mind we have angle 3 and angle 4. Right, so since those two green triangles are congruent, we can wrap this up and we can finish this off and say, well, angle 3 must be congruent to angle 4. All right, and why is that? That is by CP-CTC. All right, so let's just kind of recap. There's a lot going on there. There are 8, maybe 9 steps. If you broke up step 5 into 2, that would be okay. We started with a red triangle. All right, because the given had a lot of information about the given had to do with the red triangle. We showed that the red triangles were congruent. And then what we did is we looked for pieces of the red triangle that were in common with the green triangle, which was angle BAE and angle DAE. And then we looked for the sides that the red triangle and the green triangle had in common, which was AB and AD. And then we had that reflexive side on the green triangle was congruent to itself. So we were able to grab that and get another SAS triangle. And then using CP-CTC, we were able to say angle 3 and angle 4 were congruent by CP-CTC. All right, and there we have it. So that was how we did, what is that, number 23, that big long proof. I got 1, 2, I got 3 more. I'm just gonna make a video for these. All right, so we'll see you guys in the next one.